Hey guys, today we're talking about Pythagorean theorem, and you're going to find that Pythagorean theorem works with right triangles only. So get this information down. We have triangle ABC. They're in capital letters. They represent the angles of the triangle. And they're saying triangle ABC is a right triangle with side lengths, and you notice they're in lowercase ABC. So the lowercase a and the lowercase b and the lowercase c all represent the side lengths. If I were to measure that triangle, the length of the side length. The angles inside a triangle, which we've already talked about, that equaling 180 degrees, that's not affected with this. Every triangle is 180 degrees, but we could have small triangles, large triangles, and everything in between. So what is the Pythagorean theorem? Well, it's this fun fact. If we square the length of A, and we square the length of B, and we square the length of C, if we add the square of A and the square of B, it actually equals the length of this C. There's a lot of fun things out there for that, but this is a really cool fact because sometimes we have two lengths in a right triangle and we need the third length, and that's what we're going to be working with right now.
Schmidt, to the main office, please.
Now, I want to point out that your C value is on the opposite side of the equal sign. That's your hypotenuse, and that is always directly across from that right angle. Your legs, which are your A and your B values, those are the ones that we would add to equal that hypotenuse squared. Okay, so I want you to start looking over here at example 1. Draw the triangle. We have a 4, a 3, and then across from that right angle, which is 90 degrees, is that C length. That's our unknown. You always write A squared plus B squared equals C squared. Remember, pause the video when you're writing. Now, what do we know? Well, we know our A value, we know our B value, we don't know our C value, so that stays a variable. And then I work down, so I'm not writing across. Well, what's 3 squared? That's 9, and 4 squared is 16. 9 plus 16 is 25, and then I've got 25 equals C squared. 25 equals C squared. Hey, we've worked with that with square roots. We undo the square by dealing with the square root. The square root of 25, the square root of C squared is C, but the square root of 25 is 5. So what does that all mean? From the very beginning, we look at our triangle, and if C equals, that's our unknown, the length of that hypotenuse is 5. All right, I want you to look over here. Nope, wrong way. There we go. I want you to look over here. I've got a right triangle. I've got a 12 over here, a 5 at the bottom, and C is my unknown. And my formula for Pythagorean theorem is A squared plus B squared equals C squared. Because this is a right triangle, I'm allowed to use this. Pause the video, hit play when you're done. I'll show you what to do. So I've got...
Mrs. Wesniak, contact the main office. Mrs. Wesniak, contact the main office.
I've got 5 squared plus 12 squared equals C squared. And now I just need to do the math. 5 squared is 25, 12 squared is 144, and C squared is still C squared. Don't add across. Remember, writing below. 25 and 144 is 169. And again, you're writing this below. I just want you to be able to see it, so I'm writing it up here. So I have 169 equals C squared. Well, what did I do over here from there? Oh, I've got a square. I've got to undo it. I take the square root. Square root of 169 is 13. Square root of C squared is C. So that means my hypotenuse is C. Now, sometimes we're going to be given the hypotenuse, and sometimes we're not. So in this case, example 3, this is the case where I do have my hypotenuse, but I'm missing one of the legs. And because 5 plus 4 is 4 plus 5, you're allowed to put that really in any leg, but I put a B here so that I kept my B as the unknown. Say there was an X there, I could have picked either to be my A and either to be my B. That's fine. The only one that has to be is the C has to be on the opposite side. The hypotenuse, the one that's across from the right angle. Even if your triangle is upside down like that, this is still my C value no matter what. Okay, so I've got A squared plus B squared equals C squared. My A is my unknown, that's C. My B is my A is known, it's 6. My B is my unknown, so I keep it as a variable. And my C value, my hypotenuse, is 10. So now I got to square these numbers. 6 squared is 36. B squared I don't know. 10 squared is 100. And I'm left here. Hey, that's an equation. Don't call me after midnight. Subtract 36 from both sides, and I get B squared equals 64. Now, again, like here, like all these other places we've already seen, to undo a square, I take the square root. So the square root of B squared is B, and the square root of 64 is 8. So that means this value right here is 8. The only other thing I want to add is sometimes there might be units like inches or feet or something, and if there is, you really have to focus on that. All right, awesome.